Kirchhoff's rules can help us calculate the current expected in a circuit. But what if we actually want to physically measure how much current is flowing through a part of a wire, or physically measure what the voltage is across the resistor or across the battery? Well, for those things, we have electronic devices called voltmeters and ammeters. A voltmeter is just an electric device that measures the potential difference in volts between 2 points. So a voltmeter is really a potential difference meter. It's called a voltmeter because its units are volts. Voltmeters are connected in parallel to the circuit element you wish to measure. We'll talk about why that is in just a bit. Ammeters measure current, so they're current meters, measured in amps or amperes. Ammeters measure the current passing through a portion of the circuit. They are connected in series with the circuit element you wish to measure. So that's the distinction between a voltmeter and an ammeter. They're measuring different things, of course. One is measuring the potential difference in volts. The other is measuring the current in amps. However, they can measure for the same circuit element, but you have to apply them differently and install them into the circuit in a different configuration in order to get out a measurement. So here's a simple circuit. We have a battery attached to a resistor. I want to measure the current that's going through that battery. Now, of course, if I know what the EMF is, and I don't know what the resistance value is, I can calculate using Ohm's law what the expected current is. But if I want to know what the actual current is, I have to use an ammeter. So I have a little circle here drawn with an A to represent the ammeter device. I have to install it in series with the circuit elements I'm interested in measuring. So pretend the voltmeter is not here right now. So I'll break these lines. So you can see that there's a single loop here. The ammeter is in series with the circuit elements. So the current I that passes out of the battery through the resistor, through the ammeter, and through the battery again, it's the same current. Objects in series have the same current. So this ammeter measures the current through the circuit. However, there's a slight problem. The ammeter has to have theoretically zero resistance. Or if it doesn't have zero resistance, you've just added another resistor to this problem, which means that you've changed the current. So the current in this case, I, is equal to EMF over the resistance value R. But if there's a small internal resistance, small r, in the ammeter, now the current is equal to the EMF over the sum of those resistance values. You've changed the current by adding an ammeter. So an ammeter has to have theoretically no resistance at all. It doesn't. Superconductors are the only things that have no resistance. So by adding an ammeter, you change slightly the current going through the circuit. Usually it's a very minor change, so we don't really care, a change of 1% or less. So you can still get a pretty accurate measurement of the current going through the circuit, but by taking a measurement of the circuit, you change it. Now that's for an ammeter. Let's talk about a voltmeter. A voltmeter is added in parallel. So if I want to measure the voltage drop across this resistor, I attach the voltmeter in parallel to the circuit element I'm measuring. So a voltmeter, to be effective, has to have effectively an infinite resistance. Because you want the current to go through the resistor value, the resistor you're measuring, and out. You don't want the current to go through the voltmeter. Because if the current goes through the voltmeter, you've changed the potential in the system. You've changed how much current is in the system, and you've changed then the potential of the system. Or the potential drop across the resistor value, at least. So a voltmeter has to have effectively infinite resistance. It doesn't. Most multimeters, voltmeters, have resistance values of 100 mega ohms or 100 million ohms. So they're quite high compared to the resistance values you might be measuring of a few ohms, which are a million times higher or 100,000 times higher than the resistance values you might be typically used to measuring in lab. but it still, again, affects the outcome. So by measuring a circuit with a voltmeter, you actually change slightly the circuit properties. By measuring the current with an ammeter, you change slightly the circuit properties. So we're going to talk next about null measurements in the next lesson, and how null measurements are basically ways of measuring the current and the voltage without changing the current and the voltage even slightly. However, for most measurements, ammeters and voltmeters, like for example, if you want to make sure, see how much current is going through a wire in your house, or an electrician wants to do that, you should do that yourself, or measure the voltage coming out of an outlet in your house. The voltmeters and ammeters, the electronic simple voltmeters and ammeters work just fine. Now, usually you don't have these in separate devices. Modern devices are typically what are called multimeters. A multimeter is a little bit out of focus here, but you can change what you're measuring. So I can measure capacitance. I can measure, if I'm down here, I measure resistance values. Here I'm measuring voltage. Down here I'm measuring current. And usually the multimeter comes with these simple little probes. So if I want to measure the voltage across this resistor value, I turn it to voltage. I place the two probes on either side of the resistor, and the voltage will show up on my multimeter. So these multimeters are very handy to have for anyone who's doing any type of work with electricity. And they can range from tens of dollars to hundreds of dollars, depending on the quality of what you want to purchase. And we'll be using these in the lab. So there's another device called a galvanometer, which we'll introduce in just a moment, that can actually be set up to be used as a voltmeter or an ammeter. Rather than using a multimeter or a digital modern multimeter, you can use these very old school analog galvanometers as voltmeters and ammeters. Now, modern multimeters are digital. That is, they read out a digital number, like a digital scale. But you can have, before digital meters existed, of course, they had analog meters. And one such analog meter is called a galvanometer. And I have one here. And again, a little out of focus, I'm sure, but the galvanometer has a simple needle that moves back and forth if you plug in wires into these two outlets. The galvanometer basically, you see how there are no units on there because it can be used as a voltmeter or an ammeter. A galvanometer twitches, the needle moves one direction or the other when current flows through the circuit. The more current that flows through the circuit, the bigger the twitch of the needle. So, if you connect a galvanometer in series to a large resistor value, again 10 mega ohms, 100 mega ohms, some very large resistance value, together, those two things connect as a voltmeter. So you would take a galvanometer and a large resistor in series and then connect that system in parallel to the object you're measuring. If you know what the resistance value is of your resistor, the galvanometer deflection can tell you how much current is going through it, which will tell you the potential across that system. Now, if you place a galvanometer in parallel with a small resistor, that system acts as an ammeter. So if you place a galvanometer in parallel with a small resistor and then take that system in series with the circuit element you're interested in measuring the current through, you can actually use a galvanometer as an ammeter. Now, again, these are analog applications of a galvanometer. So a galvanometer in the past was an incredibly useful tool for measuring voltages and currents in a circuit element. But with digital multimeters, that's basically taken over by modern technology. Now, as I stated before, when you measure the volts going across a circuit element or the amps going through a circuit element, you have to add equipment to the circuit, right? You have to, in the case of an ammeter, you have to break the wire, add an ammeter, put it back together, so the ammeter is in series with whatever circuit element you're measuring. Once you add the ammeter, you add a slight resistance value, because the ammeter ideally has zero resistance, but that's not true. In the case of a galvanometer acting as an ammeter, you have a small resistor, but it still has some resistance value. That changes the circuit. That changes the total resistance in the circuit, which changes the amount of current flows through the circuit. And that's what you're measuring with an ammeter is current. So the fact that you're measuring the current changes slightly the current. Same with a voltmeter. The fact that you're measuring the voltage across a source means you're slightly changing the voltage across that source. The bigger the resistor in a voltmeter, the less you change it, but you are still changing it. So as a fundamental truth of physics, measuring an object or a system changes that object or system slightly. At least slightly, right? There's no such thing as an impartial measuring tool in physics. But there are devices called null measurement devices where we can use other means of getting currents and resistance and voltage measurements which are less destructive, that affect the system in a smaller degree. And these are typically called null measurements.